after 5 years, after 6 years, only looking at IQ. IQ is intelligent quotient, where exactly how much your intelligent quotient plays a vital role in performing in a particular company. But nowadays the companies are looking at the other quotients, that is EQ and AQ. EQ is emotional quotient, wherein you may have to manage your emotions well. How best you can manage your emotions at work life, they are looking at. That's how HRs will do, and your behavior, your attitude, attire, everything. And next is adaptability quotient. Adaptability quotient now people are looking at, because you are placed in some northern part of India. Okay, you just have to quickly adapt the environment and the people surrounding you and the culture, everything. Are the work policies in the company? So how quick you adapt, and can you able to adapt or not? People are looking at. So from this slide, I would like to emphasize that IQ is only up to a certain point, but people are looking into your EQ and AQ skills, emotional quotient and adaptability quotient skills. So please put a lot of thought on these two. And now you have to also look into what kind of jobs are more available and what kind of jobs are declining. So this is from World Economic Forum. These are the top 10 fastest growing jobs and fastest declining jobs. Coming to our civil engineering related, we can become a sustainability specialist. You can see that sustainability specialists are becoming more and more required for the society. As a civil engineer, you can become a sustainability specialist. Along with the other branches of engineering, you can see that fintech engineers, robotic engineers, agricultural equipment operators, digital transformation specialists. As a civil engineer, you can look into the sustainability specialists, which world needs these people. So you can also look into what are the jobs declining. Now, bank tellers, postal service, data entry operators, cashiers, these are all jobs are becoming redundant. These are all declining. Statistical clerks, accounting, payroll clerks, stock keeping clerk, all these are declining. So you have to look into how the market is changing, and what exactly after 5 years, how you have to prepare for that. You have to think about it. So the future of job is mostly the risk of a lot of automation is happening, and the labor market is transforming. That means less manufacturing jobs you are getting, and more of service oriented jobs. And many adults do not have right skills for emerging jobs. So all these things you have to keep it in mind, while working. So what is innovation, and how you can, drive this innovation thought? So innovation involves thinking differently, creatively, and you have to enable solutions, inventions, which can have both the social and economic value. It has to fulfill the needs of either the product or process or institutional forms, and you have to come out with new processes, creativity and things like that. So where exactly we are in? Usually the innovation is measured in terms of Global Innovation Index. So where exactly our country is? In the year 2015, we are at a rank of 81. For the last 80 years, you can see now we are in top 50 nations in the world. So we are at rank 40. This Global Innovation Index ranking, published annually by Cornell University in association with UN World Intellectual Property Organization. So that means in India, the innovation activities are increasing year by year. So this innovation index is measured by various parameters, and you can see India ranks 40th among 132 economics, So 132 countries are participated in that. Ours is 40th rank. And when it comes to the lower middle income group economies, we are the top rank. Yeah, And when we look into the Central and Southern Asia, we are the first among the 10 economies in Central and Southern Asia. So India is transforming in a very big way. And usually, this innovation index is given based on 80 indicators, 80 indicators, wherein it starts with how many intellectual IP filing rates, that means patents you are coming out with, to mobile applications, how many are created, wherein by creating a mobile application, your life will be easy. Suppose take the case of the phone pay, Google Pay. Okay. Otherwise, you may have to go to the bank and transfer the money. And also how much amount you are spending on education and scientific and technical publications. So these are all, a lot of parameters. Spot of rank 1 for the 13th year. So Switzerland is the, in Innovation, Global Innovation Index, it is always top rank. And Sweden is the second, and US is third, UK is fourth, Singapore is a small country, it is in fifth position. China is in 12th place, followed by Japan at number 13. It is the only middle income country, China, it is in the top 30. But we are, focusing more. Suppose if you take the India's parameters, innovation inputs, so patents by origin, we increased year to year. And the H index is increased. These are all publications, technical publications. And unicorn valuation also, there is software spending increased, intellectual property receipts, all these things. And again, somebody messaged, I just want to check. Hope you can see my presentation, right? Okay. Thank you. So, what is the objective of your innovation? It should either, produce a product or service. It should be affordable by more people at low levels of income without compromising the quality. This is the objective of any innovation that comes into. So now I'll give you some kind of, so having understood about where exactly we are at and what kind of job roles are there, I just wanted to understand how, the research or innovation as a civil engineer you have to take it. So I'll give you very few good points. Okay, any work you wanted to start, you have to do background research. Okay, just I'll give an example of my research work, wherein there is a report. So that northern part, there are lightweight housing, bamboo houses. But bamboo houses are there traditionally. We improved over a period of time. And to make them understand, you need to test these houses and then, make them understand these are earthquake resistant structures. So for that, I did a background study of what is the work already carried out. There was this work carried out prior to my joining of earlier organization, wherein they tested a small 8 feet by 8 feet house for different earthquakes. say, it is tested on shake table, small shake table at CPRI, wherein a input and then they simulated for 5 times just to check the fatigue of the building and also Koba earthquake. But after the test program, they've not found any kind of cracks. So one has to find out when exactly it will fail. So to test number of models of a similar building till the damage. To test number of models, again the cost is a problem because they charge a very hefty amount, and also you need a sophisticated facility, having large amount you have to spend on establish this shake table facility. So then we have moved to a different alternative mechanism of testing the building with a shock table. Within 2-3 lakhs, we could able to establish, and then we did testing for a number of buildings. So what I mean to say is, any research problem, any problem you take, you just have to do a thorough background study. What is existing and what exactly you want it to do based on the existing, data or existing information. So after knowing the background, suppose if you wanted to design, the process is, I just wanted to give you the typical information. What are the stages in the engineering design process? If you take up any kind of work, first is you have to identify the problem. Next is you just have to list out what are the various problem solving concepts or ideas. You have to just list out. Then based on 5-6 concepts, so you have to compromise with a particular solution wherein it can best fit to this particular problem. Once it is done, then you go for the either model or a prototype. So once model or prototype is working, then you go with the production or working rights. That means next stage, and then you will release, and then in mass production you do, and things like that. So these are the typical stages one will undergo if you are going for any kind of a product. So you just have to understand, what exactly you do during the process. The first thing is you do experiment. So experiment is nothing but you construct, test, verify the concept, and you do the analysis of that particular design, and you will understand whether is it workable, whether is it durable, and also you will check all the performance characteristics. So basically experiment is nothing but whatever you've designed on paper, you transform into a physical reality. So that exactly you do that. And there are 3 techniques of the construction when you wanted to put the paper into reality. So these are like called mock-up, model, and prototype. So all these 3 are different from each. Mock-up, model, and prototype. What is mock-up? Mock-up is nothing but you construct the idea into scale form using either plastic, wood, cardboard, and so forth. So usually school children they do, when they wanted to scale it. This is called mock-up. So this is used for checking the clearance, how much is required, so that you can exactly understand how much clearance is required between different components, and how do you assemble, what kind of technique is better and also what kind of manufacturing considerations, and how it looks like appearance. If you want to pitch this particular idea to someone, if they wanted to sponsor, you just have to do the mock. This is the least expensive technique, and it also gives the least amount of information. But one thing is, one advantage, you can quickly, relatively easy to build this particular mock-up. So why we do that? It is always build working models for any experiments, because you avoid basic mistakes. This is very, very important. I just wanted to mention this point. So, I just wanted to show the mock-up thing for a civil engineering example. We created tensegrity structures. We worked on tensegrity structures, wherein you can see with small, ice sticks and then, small threads. We created this. You can see that wherein it can able to take a soap box. A very interesting tensegrity structure. Okay, it can able to take a particular load, thread and then ice sticks. So these are the new structural forms. When we wanted to create, we started with what we call mock-up. So then we have built into the bigger form. You can see that the same thing with the bamboo and then the thread, a typical tensegrity structure we made. So this is scaled to a different level. That means a table. Okay, table. So to do that, we did, as I told you, a lot of design is required. At the same time, you have to analyze. You will understand what is the clearance required and things like that. So next is model. Model is a representation of physical system through a mathematical similitude. There are different models: true model, distorted model, dissimilar models. I just wanted to give you a small example. If you want to check thermal comfort inside a building, you will measure the temperature and humidity, right? But this is a small model. You can say this is called model because you cannot. We just built a small scale model wherein we put the roof and then the you can see the model, and then we measured with temperature and humidity equipment. Okay. But it may not give the exact value, but you can get some kind of information from the initial models. Then we scaled up to building a half-scale models, wherein we measured the temperature and humidity of different buildings with how the roofing roof coat behaves and reducing the temperature, and going with a different wall fabric, a different roof fabric. How can we, reduce the temperature transfer or heat transfer inside the building? So then we started making the prototype, and you can see it with the different materials and the different roof fabrics. So prototype is the most expensive experimental technique. Prototype usually full-scale working model we make, and then we will learn about construction technique, assembly procedures, workability, durability, and performance. This is one of the 7-story wood building. I was involved in Japan for seismic test at Miki City, Japan in 2009. So wherein we built actual full-scale prototype, full-scale building, and then we have tested for different earthquakes. Okay. You can see I'm just clicking the video. And somebody is open the mic. Okay. So once the testing is done, you have to understand and find out, how to evaluate. Very, very important. And you have to give a systematic representation with various notations. One small example I would like to give: when we tested this particular building, again someone opened the mic. Okay. So when we tested this particular building, for the first test we carried out, we denoted with a red line, and then the next is with a black line. The next test, that is the test number 2. So the crack progressed for the first test, and then the crack progressed for the second test. That's how the proper representation is very much required for any testing. And then One small story I would like to tell. In Japan, I used to use the bicycle during this particular to visit this particular the testing center. So then later, as I worked with the bamboo, then we like almost 12,000 kilometers. Longest ride is almost 500 kilometers. So why I have done this is to build a cycle. You need to understand what are the parts in the cycle. I can remove the parts of the cycle, and then I can refit. Can somebody turn off that mic? I think someone is speaking. Okay. So that when we are making, so we tested the joinery and then we built it. So students participated in the vertical axis wind turbine, wherein they participated. They made the prototype and then they participated in Smart India Hackathon. So when the vehicle passes through this particular wind turbine, will move and then it can able to convert the mechanical energy into electrical energy. So this particular idea got prize in Smart India Hackathon, and later it got. And our students also participated in Hackathon in 2021, wherein our ideas have taken to the final. Our students are in finalists, wherein they addressed the problem of rescuing people during the fire or during the floods and things like that. And our students, are in finalists in national innovation contests and things like that. This is the recent project I have carried out with one of the project. This is in Goa. It's a bamboo restaurant. The feature of this particular project is, I will tell you, they were not allowed. When we did the project, we have to go for a typical, because it is next to sea. So we have to go for a different kind of foundation. What we did, we have used these are the pictures of the Goa Resort project. The foundation we made by taking the pipes used for drainage, that we have taken as a permanent shuttering, wherein for foundations we have used. That means hewn pipe culverts are used for the foundation, and then we have placed it, and then rods are inserted, and then we poured the concrete. So it acted as a, because to reach it. So these kind of innovations are required even in our civil engineering projects. And just to tell you, a lot of composite materials are coming up, particularly in the construction, but there is not much analysis carried out. One has to go for optimizing these materials, new composite materials, by doing analysis. And literature review is very, very important. You need to collect a lot of information, and you keep attending and presenting in conferences, because you get a feedback on thing, and you can collaborate with new people, new field. You can improve the communication skills, and you have to read a lot. Okay. So this is as a part of my thesis. I have, so visiting different sites is very, very important, wherein it gives a lot of information about what are the existing things that are there all over country. For my project, I visited almost Northeast, and we have found what are the types of houses built using the bamboo. So, and the long-term performance is also very important. You just have to review. Suppose if you are using any kind of material, locally available material that is there, you just have to find out, how many days or how many years this can withstand. A typical example you can see here in this house, after 25 years, they've chipped out one of the bamboo reinforced arches, still a person can able to stand up on this. Next is very, very important. You need to focus on lot of standards and codes. Whenever you make a material, it is very important to find out which standard you have to make and specifications and things like that. So for civil engineers, National Building Code of India is 2005 gives a lot of information, and also you have to have a good knowledge about the Indian standard codes to build any kind of model or work. And also, whenever you do the experiments, you have to involve others in the experimental program so that they will give better ideas. This is very, very important. And also, always take proper evidences before and after experiments, not to write it down on your hand or some what we call a paper, and then the paper gone means your data is gone. Try to capture, nowadays mobile phones are available, try to capture before and after evidence when you are doing any kind of experiment for any of the things. And when you are working with any of the materials, try to test and get all the properties of such material and on a first hand basis. This is very, very important. And whatever you do, application oriented research is very, very important. When we tested large span trusses, so then we gave this particular information to the the industrial shed owners, where instead of steel sheds, they've gone for bamboo trusses in place of the steel trusses. Whenever you are pitching idea or whenever you are discussing, it is very important to have a 3D visualization. That means you have to come out with a 3D drawing wherein you can explain better and you can understand the clients or the end users. Okay. Symbolic representation is very, very important for during the experimental stage or during product development stage. And whenever you are working with a particular product, or it is very important to follow the safety standards, and you should know about how to use the equipments. And sometimes you have to design accordingly based on the availability of materials. Okay, suppose if only these materials are available, with do you design the connections? This is an example of a particular connection we tried. And also give I'll give you one very interesting story when tsunami happened. During that quick emergency in that time, typically two types of bolts are available: lug bolt and hex bolt. So even which is feasible, then we tested both for cyclic load test. We understand that lug bolt is more elastic in nature when it compared with the hex bolt. Hex bolt will cut immediately. That means not having more elastic nature when compared with the lug bolt. So even the nut and bolt plays very, very important role, particularly for some project. So even the small detailing you have to give importance when you are coming out with a particular product. So these are the thermal comfort studies we did for different houses. Taking the help of IoT is also very, very important nowadays to collect the data to make sure this house is better, this house is not, things like that. It is always have to have a good interaction with the technical person, whoever there in the lab, because you will understand, they will teach you how to use basic tools. So when I was working in US, he's a carpenter and undergrad students. Then I took his help to understand or to use all these tools. So many times students will complain about sir, I don't have a Hobart mixer to mix the mortar. So then I told him, go to a site and find out how they're doing, particularly the resin components if they wanted to mix, or grout they wanted. So this costs 1.5 lakhs. This is only 1,500 rupees, wherein handheld motor and then it mixes the mortar. So immediately they did. So what I mean to say is you have to check for alternatives of the equipment if a particular equipment is not available. Fabrication plays a crucial role, so you need to know the fabrication. That's how you have a first year. You have both welding, carpentry, and all those things, metal sheeting. So it is always to have a full-scale trials after you complete laboratory trials. This is one of the example wherein our students, made some progress in solid concrete blocks, wherein they've used the GGBS as a partial replacement of cement. They did trials at the laboratory, but later to implement, they've gone to site and then they did the full-scale site trials, wherein they could understand really how much benefit they can get. So once you have an idea, once you know how to do it, once you come out with so if you have a proper plan, you can start a company. So what you need to understand is what is the problem? Is that problem is faced by enough people? For that, will they ready to pay the price? So if you have a solution for the problem, either a product or service, you can start up. So need not worry, some other companies are solving the same issue. If Zomato is there, Swiggy is there, so but still a lot of companies are coming up. So, but only thing is you need to, structure the solution in a different way. So this is nothing but the entrepreneurship. So you need to understand the business functions. It is better to start with the co-founder because, and also you always take a mentor's help to raise the investment because they will help you out in, pulling the money. Always have a plan for what is next 6 months, 3 months, 9 months, 12 months, and also keep taking the feedback from different people. So startup having a lot of components. First is first is you have to innovate, then you have to incubate, then mentoring you have to take. You have to share the co-working space, seed funding, fabrication and testing facilities required. You need to network, market it, and then you have to accelerate the business. So all these components one has to look into it. So what are the challenges before engineering fraternity? Lot of people, a lot of population growth is there, and getting urbanized most of the parts of India, and lot of energy usage. And earlier, very few people used to have air conditioners. Now everyone is there using it. So where the energy is coming up, so it is causing a lot of global warming and a lot of problem with the water scarcity. What are the solutions you are coming out with? And about the waste management, a lot of waste is getting generated even in the villages. How do you handle it? So these are a lot of problems, challenges that are there in front of engineering fraternity. So what kind of solution you will come out with is very, very important. So having done that, you need to understand the purpose of life also. You want to choose, like you want to become rich, famous, you want pleasure, you want power, or you wanted to be live in present, help others, contributing to the society. You need to choose that, end of the day. When you look into and this is the last slide, when you look into the Maslow's hierarchy of needs, once the basic needs are fulfilled, people look for the psychological needs, like, friends, accomplishments and all. So once that stage is gone, then you will look into the, self-fulfillment, like, what is my potential, how I can contribute to the society. So with that, thank you. And thinking is a progress. Don't stop, thinking. Non-thinking is a stagnation, as mentioned by Abdul Kalam. Okay, thinking leads to action. Knowledge without action is useless. And you have to focus on your goal. Very important. Thank you so much.
Some accelerated discovery aspect. That means you are discovering something new. Okay, so that comes under ages of an research. Basically, it comes under the academic as well as industrial research. So these are the possible startups which you can think of. Whenever someone says about startups, as you all know, but it should be more concise that you should have some sort of discovery in an accelerated form so that it reach to the society for the commercial needs or for the next generation. So these are the possible tariff for the early stage entrepreneurs for things which we can see in a graphical form. So I can focus on AI powered startups. Okay? AI powered startups that which you can see about the opportunities across the various sectors. So focusing on civil engineering in we are civil, we can structural engineering, medical engineering, okay, and explainable AI is there, generative AI is there, explainable AI for all the engineering applications are there for your constructions, geotechnical applications are there, design, development, okay, structural aspects, geotechnical aspects, like earthquakes or preventing earthquakes, some methods. So all these come under the areas of civil engineering and which we can think about the next incubators or innovators for using the AI assisted mechanisms. So this is the this comes under ages of empowering next generation innovators. That means empowering or developing the new entrepreneurs, which you can see the new new generation innovators or entrepreneurs are involved in the development technology under the startup schemes. Now, you might have these two sides. First of all, it gives an basic idea about what is meant by startup. I just explained the definition of a startup infused with artificial intelligence. So now, before moving to our exact topic, like how it is beneficial or the opportunities for the students or who are there in the now, I'd like to give a brief introduction about our Amrita School of AI, where we have few forms of interdisciplinary AI associated in all the domains. Like apart from civil, we can see. I'll just give a brief introduction to these slides only. I'll take some 5 minutes to let you know about that AI in the domain and which lead to a yeah, lead to a possible startup and to be the coming era. So you see in 1980s when 80s, 1990s and PCs, internet came, only very few. Of course, in 2000s you can see social media when you're small, you like during your 10th or 12th, some platforms like IoT and what you can see the graph is escalated like anything. So where will be a career after 4 years? So this is a mark. Apart from BTech degree, you should have a startup or a research acumen, or at least an IPR, that is the patent in your domain, associated with the moving changes. Okay, that means changes which are in motion has to be recognized. It means you have to go with the flow. That along with the flow, you have to reach the goals. So that this like nowadays I will explain more precisely. That AI and robotics, automation for agriculture is one of the domain which is booming, and AI in mechanical and civil core engineering domains is yet another where it's booming. That which you can see and optimize, optimize the property. Suppose you are taking some, say, I don't know much about civil, but for construction application, you take some concrete of area or some materials point of view. But since I'm from material science background, as someone told in the introduction, I can just say that the materials point of view, like suppose you have a construction like using a concrete, okay, you're adding some, mixing some materials to get new composite. Say for example, okay, so there the required process. Suppose that you feed the machine responses. So that itself is a startup which you can give a society. So whatever you come up with and give it to society. Nowadays, I can point out one more point, that is, it is not only for students, equally beneficial for faculties also. Why? Because days while we were in our before that, there was a gap between the students and at a point of view there will be gap, there has to be gap, but some other point of view, I cannot say like in some other point of view that we can see everyone is accessible with everything. So even if you are the BTech level of 19 years or 20 years, your second year or third year, Since you have known some of the basics, fundamental, of course, the faculty will have more than plus or 10 to 15 years bigger than you. So his or her expertise will be far, far ahead. That is a different story. But what I try to bring is that this startup is applicable equally beneficial for both students as well as faculty. Let me explain how. Like you use the technology of methods and different machine learning models or deep learning models. Nowadays, you can see any source of GPTs and GPTs for us and many more as available as a fingertip tool to explore what is the recent domain. And that apart from that, there are many benchmarking domains, benchmarking data sets are available, wherein which you can get the data which is experimentally proven, and that again you can remake it and you can even own experiment. So what projects you are doing, embed it with some technology, and you can give as a patent or a startup. So lecture, yeah, do an interaction. So I'll be having an interaction session also. That means at the see what is the beneficiary point of is that you are getting some output from your engineering domain. Say, for example, the projects you are taking. You should not concise that project in just a report. You should explore the project by using some computer aids or methods, which is on track with the current scenario and topic, so that commercial purpose. This is nothing your startup. Okay, so AI material science you can see recently I've seen a paper in solving. Yeah, sustainability AI is doing like anything. So sustainability, geotechnology, environmental science. So in everywhere, so earlier these AIs you can only there was a confusion that only computer science people can use AI and it is allied only to computer science. Moreover, now I tell you that AI interdisciplinary domain has boosted like or boomed like anything, which can't be compared with any other domains. That includes even with the civil engineering applications or material science applications, civil engineering applications. Okay. And now we can see about what are the one number like just graphical tool uh, all comes under one interdisciplinary line. So it is an how to go called as multidisciplinary, like a visual, like you can see a hub of all the colors. One is yet which achieve a super paradigm that is MAPT, or we can big model, closed loop design, automated and intelligent systems, discover new materials. Yeah. So it is and of your models of your iron or steel rod, you get the remaining non-linear behavior. So, like that, the technology is moving in such a way that you have to come up, you have to stay ahead and think about for some novel methods or finding which you are going to discuss today's session. So, this comments on all the aspects of AI, new AI, novelty of AI, various domains. Then I'll move on to the types of startups there which can be utilized for your from your subject expertise. So that, let me explore as AI. So you may what can how I explain more about it. Like, these are the points you get to say. Something called as bioinformatics, chem informatics. So you might have heard about biomechanics somewhere. It's nothing but the whole biology and chemistry. So I can tell you that even biology and chemistry are embedded or infused with AI. That means AI can eventually AI for system, eventually AI for system. The civil domain comes in the last portion, that is AI for materials discovery. Yeah, one second. Hello. Yeah. No problem. Yeah. So sorry for the disturbance. So these are the different aspects of AI or different applications of AI which we can see about what are the different domains of AI. Yeah, different domains of AI, wherein which you can see the applications of AI, which can lead to new startups. Okay, and now I can talk about how in healthcare AI is capable of reducing diagnostic costs. So you have one question in your mind. So today's topic is about accelerators or incubators. You're talking only about AI. But the answer for this question is that you can see many of the sponsored research projects. So basically, startup means you should have some funding, some resource funding from somewhere, or you should have a platform to explore that idea. Correct? But the platform nowadays they have changed based upon the technological advancements, like by incorporating AI or some other computational aspects. You can see it's a density function theory or something like that. In computational aspects, you can see that you are able to explore novel materials at a cheaper cost. So this is the advantage. Cheaper cost instead not on the cost. Like obviously the cost is there for purchasing the system or a server which high configuration. That is okay. That is only one time investment. But apart from that, you can avoid large number of experiments, cumbersome tasks, and labor cost and materials cost by implementing the concept of AI. So whenever you're proposing a startup plan or a patent or IPR, okay, you can see about some applications of AI embedded onto your structural aspects. So that means it should be blend of AI and structure such that your civil property should be matched with the AI property. Or another way, I can say like you can get the benchmarking data sets available. So you may be asking me second question, sir, from where we can get the data and how we can do, how we can learn AI. That is a fundamental question which I should address you. That is first of all based upon the softwares, and there's some tools like Python or MATLAB where in which you have many methods toolbox associated with it, where in which you can explore on the particular type of machine learning model or deep learning model. That is on one side. Okay, it will come on the go. But apart from that, most important thing is the data. From where you get the data. So regarding the civil domains, you may be having some benchmarking data repositories in which you can get the initial data, like material property like that. With that data, you can feed into the system. Because AI is a data hunger method. See, for the machine learning aspects, data is less. For the deep learning, more data, even for large language models, it's a data hunger approach. So particular input data and the data processing is required. And based upon the data, you can see that some responses are obtained, some optimized responses are obtained, and based upon the optimized responses, you can validate for the experiments. Here, the advantage is that you can get the end product with less number of experiments, or some with a new, precise, and accurate form of things using the applications of AI. So, with this, I can say about how AI is embedded onto your incubators and the advantage of AI if it is embedded onto your incubators or accelerators. Okay. Now I can focus on the your what do you mean by accelerators and incubators? What is the difference between accelerators and incubators? Title itself shows accelerators, incubators, opportunities for students and faculties in relation to early stage entrepreneurs. This is your title. But now I would like to say what is the difference between accelerators and incubators. So accelerate basically the programs that offer mentorship, capital, and resources in a fixed term, cohort based format. Whereas incubators provide organizations for stage startups with office space, mentoring, and basic resources for a longer period. So, I would like to explain basically what are the difference between the accelerated and incubators. Incubators, I can say, it is just a nurturing your idea. That means it is a long-term goal wherein which you can develop a product type and you have got the time to validate the product. It's a long-term process which requires only a very small office area and which is mentored by your own faculty. So incubators you can see in many colleges. Incubators you can see in many colleges. Accelerators it is so it should scale in such a way that it should scale up your product development in such a way that it can be commercialized for the public. Suppose, say for related to accelerators, if you want to develop a product which can sustain earthquakes or like some related to your environmental issues, okay, it is actually a rapid growth and scaling is required because that is an ultimate requirement for the society. So that comes under the aegis of accelerators. So these are small basic difference between accelerators and incubators. And we can see about the benefits as we all have access to fundings, network opportunities, mentorship, funding opportunities, educational resources, collaborations, shared resources. All these comes under the benefits of an accelerated as well as incubators. Now comes the main part. How do you see there is an opportunity in the students? Opportunities in the students basically resources and mentorship for tuning the ideas into startups, skill development. I'll explain each and every one. Practical experience in business development, technology and innovation, research and development, building connections with industry profiles, industry academic collaborators and potential co-founders, and funding opportunities, early stage funding and pitch competitions. Hands-on experience enables employability and entrepreneurial skills, which can in turn affect your resume and have enrichment. Join entrepreneurship clubs, apply to incubators, participate in hackathons, etc., and pitch competitions. So this slide is the most crux of an opportunity for the student's point of view, which in turn affects your career advancements in future. So all of you can just go through a slide. This should not be a class. It should be an interactive way. But one is startup support. What do you mean by startup support? What do you mean by skill development? What do you mean by networking? What do you mean by funding opportunities? What do you mean by resume building? Okay. The last one is okay. Last comes at the part and parcel end effect of all the former mentioned ones. But first of all are most important for you to explore and get to know about the opportunities of a startup. So first one, startup support. Startup support, I'm just bringing that startup support in just one line, but you have to explore what this the startup support in a document of not more than 100 pages. Why I have given 100 pages is that this one line should lead to 100 pages. That means you can imagine like how it has to be scaled up. That means access to resources and mentorship for turning ideas into startups. This is the most important and the very basic, very fundamental aspect of a startup support. So I just wrote in a one line, this you have to explore more and more, dig more and more to get the benefit out of it. I want to do more case studies into it and bring down a report of 100 pages. That means why I have mentioned that 100 is that one line converted to 100. That means you have to explore what are the different resources and mentorships for tuning your ideas or turning your ideas into startups. This is the most fundamental part. And the mentorship and the resources. See, this, say for example, there are many industry sponsored research projects in which an industry person will be your co-mentor, your official academic person inside your college will be your main mentor, and you can carry out a research project. Immediately after your BTech, you can apply for that. This is one of the startup opportunities. and for that you can get direct interaction with the company. Preferably they have with central government companies, but their obviously their application will be on their domain only. That is okay. But at a later stage, if you can learn something out of it and you can convert that to some structural lab, for example, I can bring out my point of view. Like when I was doing my MTech, I worked under a civil professor. She was doing an structural engineering design on launch vehicle design structures, where which was explored to structural aspects with cryogenic temperatures. The structure was exposed to cryogenic temperatures. So that is preferably civil engineering domain. But my MTech was in engineering design. But that idea, which I learned from that, what I have done is I have implemented another small structure using the FEM method. We have developed that structure. It's something known as hybrid composite structure. We use a different type of material. We're having the composites, having the two properties, and then it has been published in a conference. Yeah, and like that, it was even tried for a IPR, but unfortunately we didn't get it. But okay, fine. But at least find the resource for how we can approach for turning the ideas into a startup. This is the fundamental and the most important, and even the end point of your startup. See, the startup doesn't have one starting point and ending point. Once you start, you have to go with the track. It is like a railway track. It goes on, moves on. It doesn't have an end point. It is like a common straight line, one straight line. Because there may be some conjunctions or interceptions between the startups, but your idea or patent should not even change. You should not deviate from the envisaged idea which you have. Point number one, which is the most important thing. Obviously, there will be some alterations which can be done, but you cannot change the entire theme one after the other, like year after the year. So while developing the startup support and access to the mentorship and the resources, you should be very careful while choosing the topic and your potential of the application of your project. Okay. Second one is skill development. Skill development I need not want to explain. Why? Because it comes under day by day exposure, practical exposure in business development, different strategies taken, technology, research, development, and innovation strategies, which comes under the part and parcel of that your startup topic which you have taken. But the first and the foremost is connected to the second one. It is interconnected. It is like a base of a building. Once the base of the building is formed, if it is strong, the building will be good. Yeah. Since it has to be strong in such a way that you have to ensure that it has to be strong. That is under you or within yourself. So that is the first startup point. Second is skill development. Third is networking. I can see, and fourth one is I can see about the networking. Yeah, third one. Coming on to the third one. So building connections with industry, academic collaborations, potential co-founders. What even the co-founders, they may have some their own startups. So in that startups you can work. Okay. And second is and consultancy. Consultancy comes under networking part. Funding opportunities are there, and for your interactions and many funding for the startups. Okay. Now from the government as well as. Now, the second comes the opportunities for faculties. Okay, so opportunity to faculties basically to enhance their research acumen and industrial academic collaborations. So engage with the university's technology transfer office, mentor student projects, and collaborate on the startup ventures. So basically, you can see all the interdisciplinary, intersectoral research. Most importantly, research commercialization, collaboration, funding from the many government research fundings. Okay, sponsorship projects, mentor roles, sponsored webinars, sponsored faculty development programs, sponsored lectures, invited lectures, everything contributes for your professional development as well as personal development and the research acumen of that particular faculty. Yeah. So this slide I'm just traversing through because this, of course, I'll be sharing the slides and you can just see to it like what are the different aspects concerning the faculties. Last but not the least, I can just put in a nutshell that student startup that scaled to an accelerator program, faculty-led research project that was a commercialized incubator support. What are the importance of mentorship, resource access, and collaboration in startup success? See, you see these three terminologies, your mentorships, okay, resource access and collaborations in startup success. This is the most important point, okay, which I've highlighted from the entire slides. That is your, you can see about how it can be mentorship, resource access, and collaborations. All the 3 points, first, second, third, that is mentorship, resource access, and collaborations contribute to the hard brain of your startup success. Okay. Now you can see this university resources, online platform, networking events, government and private sector initiatives, grants, funding programs, ecosystems, yeah, circular economy, many fundings are available, sustainability, many fundings are available. Okay, regarding construction, sustainable materials, most importantly, as far as I know, most important funding is given for sustainable and environmental to bring the circular economy, and conferences, meetups, seminars, invited lectures, faculty development programs, yeah, webinars focused on startups and innovations are yet in the platform. And of course, you rely only on not only on this, but the online platforms and the university resources for the connecting to the startups. Yeah. Now we can see about an interdisciplinary team that benefits both students. So it should be an interaction between students and faculty